Welcome, everybody. I decided to cheat in the age of AI. So join us for our upcoming webinar, Embrace Platform Engineering to Deliver Business Value, where you'll discover how harnessing the power of platform engineering can propel your organization's success, learn how to optimize your technology stack and innovation capabilities to drive tangible business outcomes in this insightful event. How did ChatGPT know this was going to be insightful? Let's see. Seriously though, talking about platform engineering, I think this is going to be pretty interesting. It seems to be one of the hot topics lately. Everybody, the whole industry is wondering how to do infrastructure as code better, how to do DevOps, how to update your pipelines, how to move to more cloud native and microservices so you have a decoupled monolith, which of course brings its own kind of challenges. How do you get all these microservices talking with each other and everything going? And a whole lot of challenges. And it really adds into putting a lot of extra work sometimes on top of developers. So how do we keep the developers delivering business value and not worrying about underlying problems of how these pipelines are supposed to work and how to set up infrastructure and whatnot. So putting it all together in what we can call a developer platform is an easy or a way, an approach to do this. My thesis is that every company out there who delivers anything with software has an internal developer platform. The only question is it you have a sticky note on your desktop that says, yell at John when you want this to go to production? Or do you have an automated and repeatable tool with certain processes involved? But platform engineering is kind of the hype lately. We've been talking a lot about it. I do have a quick agenda, what we're going to go through today. I'll babble for another minute and then we'll start a poll, and then we'll have Thomas and Nuno, and I'll introduce them as we're getting started, and then we'll have a bit of a panel discussion. I would encourage you to go ahead and put stuff into the Q&A and or the chat if you're able to, but I would encourage you all to use the Q&A and put in your questions, and we'll have a bit of a discussion after the two presentations on, and bring up your questions and talk a little bit more with our panelists. So to get things started, I thought we would have a quick little poll just to see where you are. So if Dorina can throw up the poll for us. There we go. Are you using an IDP? And here I mean more than a sticky note that says yell at John. Are you using GitOps for infrastructure as code? Are you tracking the DORA metrics? And Backstage has been kind of all the rage. So are you using Backstage? No, planning to, it's in testing or it's in production. Well, continue to fill that in. And I think we will take a look at that after the discussions. So first up, we have Thomas from Bankdata, and he's going to talk to us about what they've been doing over there. Over to Thomas.
Perfect. Thank you, Andy. Yes, hi, I'm Thomas from Bankdata. Started out as a developer back in 2000 and leading teams for the last 10 or 12 years, the last 3 years platform teams. And I called my talks, Embrace Platform Engineering, make your developers happy with modern tools, stability and ease. So let's get started. Yeah. This is my agenda. Just a quick introduction to Bankdata. Who are we? Then why we need platform engineering and how we organize for platform engineering and developer experience, some of our guiding principles around that. And then I will dive a little bit deeper into three topics. That the first one is the challenge of the vast tech landscape, meet the robots, and finally develop a portal as an abstraction layer. So that's the agenda for today. Okay. Yeah, our vision in Bankdata is that we build the future of digital banking. And we are close to 1,000 employees. Normally we say we are between 500 to 600 developers or engineers. And yeah, We have more men than female, but we are striving for the diversity and attracting more women. We like that. And Bankdata is just a great place to be. We have people staying with us for a long time, and we are proud of that. And we make IT for banks. We are owned by 8 banks, 8 Danish banks. The biggest one in our, between our owners is the second largest bank in Denmark called Jyske Bank. And we make all the IT solutions for the bank employees and also the end customer, the Danish citizen or the business user. And we have a lot of them. We also have a lot of accounts, and we also have a lot of transaction every day. So we deliver critical financial infrastructure in the Danish society, and we are proud about that. Yeah, so that was Bankdata. Yeah, let's move on. Why we need platform engineering. And Adam put some good notes on it in his intro. I will start with a definition. So what is platform engineering? And this is one definition, and it's by Luca from Humanitech. It's one of the companies I follow in this space. And it's all about the discipline of designing and building tool chains and workflows that provide these self-service capabilities for our organization within software engineering. And it's about platform teams, platform engineering, making a product and delivering this product to the developers. Normally we call it an internal developer platform, and it actually takes care of everything they need in the daily works. And that is from start to finish of the applications that the Streamline teams are creating. And why is this important? It's very important because if we don't take this seriously, we could end up in a situation that looks like this. So this could be a symbol of a very bad developer experience. And if a developer is in this situation, the documentation will probably be scattered all over the place. It could be Confluence, OneDrive, SharePoint. Infrastructure could be thrown towards the developer so that he needs to know what to do with the infrastructure and the tooling. We could have a lot of different tool stacks that are very unique and individual, so that it's very hard to onboard new people. And along the way, you probably jumps onto DevOps and you talk about your ability to run it. So you expect that your Streamline teams, they will shift left on security, shift left on testing, shift left on compliance, and the heads will just go a lot of cognitive load. That's not easy to be effective and deliver business value when you have a fragmented developer experience like this. So what if we could do something more like this to our developers? And I don't own a Tesla, but I know there's a lot of complexity in a car like this, but it's abstracted away. It's put beneath the surface. There is an interface. There is a streamlined interface with this screen, and you can drill down, probably get down to some of the complexity, but it's not on the surface. And I think this is a symbol of probably a better developer experience. And this is what we strive for in Bankdata. It's to give a better developer experience for our developers. And we actually organize towards this. So this is the business area that I'm a part of. And please notice that we actually put in developer experience or DevX in our area and also in many of our teams. So this is something we mean. And we made this organization in March this year. We had a platforms team before that, but right now we are really coming together, really focusing on improving developer experience and talk a lot about platform engineering. So Sarah, she has the two first team, a team that makes developer experience the tooling side for mainframe developers and a platform team for mainframe platform. And I have a DevX team for Java and front-end developers and a toolchain team. And Tom, he has runtimes outside the mainframe, and integration. And Carsten, he has developer experience for our Microsoft and cloud developers. And Simon, he has great people that know a lot about processes, and he also has agile coaches. And in the end, Vibeke, she has our UX area with all the UX people out in the Streamline teams. And there's a lot of skills in this area and in our great teams, and we can really use these people to make a better developer experience. And we are doing that. And that is something we start on now, moving into 24, and we'll probably keep doing that because it's important that our developers can be effective in the daily work they do. And of course, we are, like many others, inspired by team topologies and the concept of platforms team and X as a service, really thinking about self-service. And we talk a lot about guiding principles right now around developer experience. And we have decided on these 5. So it is minimize cognitive load, enforce self-service, enhance discoverability, high availability tool stack, and reduce wait time. And we are really focusing on this, and this should be 5 pillars that we stand upon and that we measure our initiatives on. So if you ask developers in Bankdata in half a year, in 1 year, in 2 years, they should all say that they can feel that we have improved on these 5 guiding principles. That's our ambition. Okay, let's make a little more deeper dive into 3 topics, as I mentioned in my agenda. And the first one is the challenge of the vast tech landscape. Because I work in banking, and our tool stacks and our solutions sometimes have a longer life cycle. And that means that over time, you will create a big tech landscape. Of course, we are focusing on this. We have also a heat map. We try to consolidate, but it is a vast landscape. And it's not something that we can just change overnight. So what do we do to improve developer experience? One thing we do is that one of my teams, and this is kind of a fun picture, it symbolizes a hydra, and it's because that we strangle some old tooling because we are modernizing and standardizing our tooling. So we have an old source management system and an old build system. And again, when people come into Bankdata, they need to learn this old stuff. It doesn't make anybody happy. So what we do is we have actually consolidated on newer tooling. And then I ask some of my great developers, okay, so we are working with this. If you get the new tool chain instead with Git, IntelliJ, and pipelines, instead of the old tool chain with RTC, that's an old source management product. Eclipse, that's an IDE, and build monolith, that's the old build system. What is this? Is this valuable for you? Can you onboard more effective on this new tool chain? And they said to me, this is great. We can probably onboard 2 to 3 times faster because today they know about Git from the schools, or if they come in from outside Bankdata, they also probably know pipeline and what the mindset is around pipelining. So we can onboard much faster. This is really valuable for our organization. And on top of that, when you are moving more and more of your older tool stacks onto the new tool chains, you can integrate compliance and security into one more unified tool chain. That's really valuable. So you don't need to put in security and compliance on all the individual old legacy tool chains. So very, very important. And actually, we also do this on our mainframe. So we have a lot of mainframe. That's a big part of our core banking system. And we have created a better developer experience and a new development platform for Cobalt. So this is VS Code. you can write Cobalt source within VS Code. We actually on the right side have a Cobalt, a unit test framework we call Cobalt Check that we open sourced, and you can run local unit testing on your Cobalt application. And of course, this hooks into building with Jenkins and the binary artifacts into Artifactory. So again, the new mainframe developer platform also uses the same toolchain as our Java microservice running on top of OpenShift. So very important to go towards have a unified toolchain. And yeah, the developers on Cobalt, they like this feature. Of course, we have an old, very stable tool product, and we are starting to creating a better and better experience on the new one. So great work. Okay, that was how we go head on the challenge of the tech, the large tech landscape. Okay, let's meet the robots, because it's all about self-service, or self-service is a big part. And we also had reduced wait time and reduced cognitive load as one of our guiding principles. So this is Sushi, Ove, and Gonzalez. And yeah, Sushi. Sushi is a big part of our internal developer support. So we have 500 or 600 developers. They will probably lead the support at some point, and they will make a ticket. That could be an email, that could be a Jira ticket that they send in to us. And we have Sushi sitting in this switchboard, and she is reading. She's a machine learning algorithm. She reads every content in the ticket, and she ships it to one of the teams. And in the teams, they have a primary supporter that will look into this, be assigned, and then we have it on a Kanban board, and the person needs the support, and the primary supporter, they can communicate around it. Why is this important? It's important because before Sushi, we had a person sitting there. And that was not the favorite task of the day, to being put in the place of Sushi. And Sushi, she's doing a better job. And of course, we get these tickets screened quicker, we get tickets resolved quicker, and actually we live up to our SLA in 95% of the time. So we also have happy developers. So this is one example of using robots to create self-service and reduce wait time. We have other robots. So this is Gonzalez and Ove. And Gonzalez, he's actually doing a great job, because the platform team that operates our OpenShift container platform, they are getting a lot of pull requests that they need to approve. And that's actually around 1,500 each year. And before Gonzalez, we had to do that more manually. Now Gonzalez, he takes care of up between 1,100 and 1,200. So that's like 75% or around that gets auto-approved. So when you make a pull request, Gonzalez, he would look into it and he would try to auto-approve this. And you need to read these examples from the bottom up. But in this case, the next one from the bottom, that's Ove, or approver. He say, hey, you need a change number. I cannot approve this yet. But again, he tells the developer, hey, if you need a change number, just make a comment with plus change and I'll make it for you. And the developer, Julia, in this case, she comes into this, she gets this notification, she writes plus change, and the robot, Ove, he gives the developer a gift. Here you go, here's a change number. And Julia, she can make the final approvement, and this will move further into the development flow. So again, small examples of robots making it easier for developers to have a great flow and take manual processes out and put in robots to reduce wait time and reduce cognitive load, because the robot, they give the developer some context to make sure that they can easily move on. So that's just some examples of what we are doing with robots. And I know that on this journey with developer experience and platform engineering, we will do even more. Okay, next topic and final topic for me, that's to use developer portals and as an abstraction layer. And I will just quickly introduce Backstage, as Andy talked about. There's a picture from Backstage. And what is Backstage actually? So Backstage is an open platform or framework to build developer portals. And it was created by Spotify like 7 years ago. And in 2020, they open sourced it under the CNCF, just to make sure that this would be adopted by a lot of companies, to make sure that it will be a platform that was strong and with a lot of contributions. And that has happened. And I heard this phrase in a talk I saw the other week, the thought of one bookmark. So a developer should think about Backstage as one bookmark or one-stop shop or single pane of glass. So it is the cockpit that a developer needs to be able to be efficient and create value for the business. And what we are doing in Bankdata is actually, we are experimenting with Backstage or developer portals at this moment. And we are looking into the core features, that is software catalog and ownership, software templates, tech docs and search. And there is a lot of plugins out in the ecosystem of Backstage plugins. We are taking relevant plugins from there. And we also consider some of the premium plugins that Spotify has created. So Spotify says they have around 200 plugins in their Backstage, and they are taking some of these plugins and make them as a premium bundle. And yeah, I think we could use like Pulse, that is engineering satisfaction surveying. They also have insights and something that incentivize developers to improve the quality of what they own. It's called Soundcheck. We look into that as well. So a lot of great stuff also in the premium bundle. And the timeline, just to give you an insight into that, we started around start of Q2 this year. Right now we are making proof of concept of these core features, and we are pitching this internally to make sure that this is kind of the way to combat developer experience, to have this developer portal as the one bookmark for our developers. And we expect to go into production late Q4 or Q1 next year, and investing into golden parts and inner sourcing. And in my opinion, a lot of our 5 guiding principles, a developer portal will improve on those guiding principles. So that's just great. Yeah, and finally, I just want to give you a little sneak peek into our experiment of proof of concept. So this is just an overview of APIs, and you can see who owns different APIs. If you click on an API, you get a view like this. You can view the source, you can view tech docs, you can see the owner. We have just played with integrating a SonarQube plugin so that we can see the SonarQube status of this component. And if you click on definition, this is an open API specification, so you get a nice and visual documentation where you can get a great overview of this API. And we have also integrated with the Linda feature by Zalando. So we can actually validate this API towards the best practice from Zalando. So that's also very powerful. Yeah, we also have software templates. So we have made some proof of concept, creating an Angular project or a Spring Boot project in a standardized way. So this will be our way of standardizing how we create new projects so that we can bake in compliance and security. Yeah, and finally, Backstage has a great feature of showing ownership. So you can look at a team, how much they own of different components. And yeah, that was just a sneak peek of what we are playing with Backstage at the moment. And yeah, it all, in my opinion, it all comes down to this, making a great developer experience for our developers and abstracting away infrastructure, tooling, and streamlining documentation and templates so that developers can use their time to create business value. So that is our ambition in Bankdata. And that was my presentation. Thank you for listening.
Hello, everyone. My metaphor for the slides isn't as clean as a Tesla. Sorry about that. It's about derailers, and that's why it's called gear changes. Why? I'll get into that in a bit. Who am I? Nuno, Cloud Compute Lead at Millennium BCP. So basically, I have 3 teams with me: automation, cloud compute, and observability. And for those of you who don't know Millennium BCP, Millennium is the largest privately owned bank in Portugal. And I like to think that we do cool stuff. I'm a part of the Cloud Center of Excellence, as we use cloud as an excuse to do all these transformations. If you want, you can find me in LinkedIn and talking about derailers. So as I was saying, probably we should have the question, the initial survey about who does biking, who has bicycles, because the analogy here has to do with derailers, which is that system, for those of you who aren't familiar with it, that as you continue to pedal, allow you to shift gears without actually stopping. You just select the gear and something pushes the chain to your new service selection. Let's use that analogy. Why? Because one of the paramount things that we're trying to always keep in mind is this duality where change is constant and service is continuous. But how do you do change if you always have to provide service? So this was our initial driver into this big story of automation. So the road so far, we've been down this road for a bit over 2 years. I think we actually started whiteboarding the thing spring 21, and this idea brought us to something we call the MSA project. MSA from Modern Services Automation. And the driver here was, well, I think everyone can relate to this sort of thing. People sending emails or service requests into the MyTSM tool and having an expectation, and those emails not being read immediately or not being executed within the requester's expectation, or having incomplete information. We all know what this is. And even if someone actually delivers the thing in time, perhaps it's not exactly what the requester wanted. There's some bug, there's some configuration missing. Traditional pain points we all know. And again, as we know, this starts building up these two cultures where on one side you have people with this feeling that they never get what they need, at least on their first attempt, and that they aren't important enough to be serviced as they think they should be. And on the other side, people saying those guys never make up their mind, they always want different things, they're always trying to ask for things we do not support, and all of that. And we were going down that path. Again, most of us know, which is quick management decisions, like throw more people at it. The you build it, you run approach probably works for Amazon, for instance, but not for us. We cannot expect developer teams to have the right knowledge, even permissions in some cases, to actually be able to run some things. And the expectation that there is no cognitive challenge there really makes no sense. We're ignoring cognitive load with that approach. And if some companies struggle a bit with finding the right skill sets on the market, we, and I'm sure some of you as well, struggle a lot to find people with the right culture, training, drive, etc., to actually be able to make this a thing. So if we had to summarize the driver behind the Modern Services Automation project, and going from top down here, we said, okay, we need to offer the right options. We need to cut cognitive load by asking developers, for instance, what they actually know. And for that to happen, we need to design the right interfaces to, well, interface with those customers. To do interfaces, we need to sit down and actually have a proper definition of what that IT service is. And it's not just a matter of saying, oh, it's called whatever, and the request form has 5 fields. It's always a matter of then what happens on day 1, on day 2. How do we do lifecycle management for the service? How do we observe the service? What should we expose about the service, and so on, leading to service requirements. And to be honest, some of these services that we now share with our internal customers through this new set of interfaces, things as basic as storage, actually required us to re-implement the internal management layer for that service, because it made sense. We were not looking at the service in the right way. So what this means is that our initial slides back in 21 had this big message saying from 8 days to 8 minutes. That was our goal. We wanted to have people go from whiteboard to production. Now, considering writing code were, okay, 30 seconds to write code, we can slide that in there. We would take 8 minutes to make things happen enough to get that service into production. And how? Self-service. The requester knows what he needs, so we just need to help him get what he needs within the right boundaries. We need to wire up the code. Developers should not have to always write the initial code for whatever the developer is implementing. We should provision everything that has to do with developer environment, and we should have full automation on the infrastructure resources. And again, it's not just day 1, it's a whole life cycle for the resource. So back in 21, we started wiring this up, making tough decisions and getting a plan going, so that early this year we GA'd this internally, and we now are pushing codes with all of the concerns that you can imagine an FSI, a financial services company, needs to have in place. We are pushing code, we are pushing infrastructure resources pretty fast, pretty efficiently. So developers start working on an app in under 10 minutes, just interacting with a web UI. We scaffold the code. We do service discovery for those services that the developer is writing and those services that the developer is interacting with. And so things work. We have moved from this up to 1 week service request closure time to 8 minutes, and from an actual effort of around 8 hours of people doing things in systems to a just-in-time approach. The only thing that is not driven by the product team, by the development team, is day zero, where in day zero, there's a task where an SRE registers that product team. So we have a Terraform module with a dozen variables, typical stuff. What's the name of the team? Who are the developers? Who's the manager? What's the cost center? IT business stuff. And by running that Terraform module, which takes about 15-20 minutes to actually run, we write the right stuff to all of the environments. We set up everything that needs to be set up so that the developer, when he starts writing the first service, can properly do self-service. And I don't mean we will deploy databases, for instance. Here, this is about registering the right information in the right places. It's 300 to 500 Terraform resources because we're doing things like monitoring dashboards, validation rules, cost budgets, all of the ecosystem around the resources that then are deployed by developer interaction. And what's that developer interaction? So basically, the developer goes out to the internal services catalog, and I have a couple of screens to show you, and we take his input and generate stuff. Stuff being repo, initial code, pipelines, boards, whatever. And also, of course, wiring this up to our tools like SonarQube, checkmarks, and so on. So basically, from this screen, from this backstage screen, you can, of course, get details on your service as well as the services you connect to, because teaser, one of our CD pipelines actually gathers this information and pushes it back to backstage. But you have templates not just for your code, but for the whole dependency set for your code. So for instance, if you say you're going to build a new microservice, you end up at a form kind of like this. There's a couple of fields further down. And you're basically saying business stuff, name, business domain, system, topology. And then you have a couple of choices that have to do with, does it use cache? Does it use database? Does it use messaging? And with that information, we set up what needs to be set up to support from an infrastructure perspective and from a application lifecycle management perspective, that product, that service. So for instance, looking at the screenshot back in 22, we were doing 4 minutes to set up a service, a development environment for a service. And of course, then we start doing automation. We check code quality, vulnerabilities. And I think the most relevant bit here is that application, one of the files generated there is an application definition file, a JSON file, that says, as I was saying, it needs cache, it needs a database of SKU small, and so on. We get that information, and here on the CD pipelines, we convert that to an OAM format, an open application model file. And that information basically means typical OEM image from the OEM site. This says, okay, this application has these components. In our case, there are a lot more components here than just the web service, because we'll do observability, identity, storage, databases, cache, messaging, both topics as well as schemas, for instance, and a couple more things. There's a workflow and there are policies that we identify from both the selected pattern as well as the choices the developer made in terms of dependencies. And this is what then drives pushing the service with its dependencies everywhere. That file ends up in a Git repo. We use Flux and Customize to actually select the cluster and push it into that cluster. We have Kavella in the cluster. It knows OEM and knows how to typically convert those components, for instance, to claims in the cluster that Crossplane picks up and actually starts ensuring the infrastructure dependencies are there. The connection strings, for instance, are wired up to the application and so on. And to get this in place, we basically selected some champion teams, did the typical flow here, define initial gap, training, having product teams next to them, pushing them to do the right thing, and basically ending up at a set of KPIs where, although I'm not showing you, I hope you believe me, where things like total hours saved, customer satisfaction, and infrastructure resources created by automation were at a level that we were far from before having this. Now that we've moved past the MSA project, where are we? So now we have sets of specialized teams to manage cognitive loads. So it's up to product teams to handle the challenge of, for instance, understanding how to implement compliance on an automation and how to put that automation into Crossplane or Terraform. It's up to the delivery team, where we have SREs, to actually understand how that can be relayed to developers and to bridge that on a day-to-day work. And we also got 5 new internal IT products. So now we have a service catalog that is populated from these interactions that the developer and pipelines do. So we have visibility and discoverability of these APIs that are being simply implemented by the developer. There's no requirement for the developer to push files anywhere or whatever. Automation brings visibility to what is building. Then we have this full ALM, application lifecycle management automation, for everything that has to do with repos, pipelines, teams, change management, because we also do automated change requests, standard changes, opening and closing changes, and all of typical ITSM requirements for this sort of ALM. Now we have a set of APIs called Workload Manager that know what IT business is. When I was telling you about cost center, manager, development team, and so on, this is managed now from this central point of knowledge, which is the Workload Manager, and all of the automations now know where, for instance, to get the right tag values for a resource. All of the observability knows how to escalate an alert, because if they need to know who the manager is, they just need to query the Workload Manager, for instance. So we have full IT business visibility. We have resource manager because this is basically our library of automation that not only knows how to create a storage resource, but most importantly, knows how to do compliance, auditing, security management, all of the concerns surrounding resources in the correct way, at least for us. And then we have an app control plane that basically is that layer that knows how to get, for instance, an OEM request and do things with it. Manage the application lifecycle through automation from end to end. And if tomorrow, for instance, the developer decides, now I want my application to have cache, the only thing the developer needs to do is to edit that service definition JSON file and say, yes, I want cache. And we will wire up cache. We'll start Redis cache instance. We know where to push that connection string to. We will make that work. So now we have APIs for our most common stuff, databases, caches, and so on, as I was describing earlier. Multiple families, because you can ask for a database in single source, Microsoft SQL Server, and Cosmos DB, or whatever, and multiple SKUs, because you can have t-shirt sizes for this, from extra small to extra large. And honestly, the challenges that we get now on an operations level, on a day-to-day support level, has to do with things like the developer saying, where is my database for my service? And typically, either the app definition file doesn't have a request for a database, and the developer needs to edit that and say, no, I actually needed a database, thank you. Or the eventual reconciliation loop in whatever management cluster is taking care of that resource got a transient error, it's going to fix. Now it's eventual consistency model, so it will get there. And even if it doesn't, because, oh, we pushed a bug to production, for instance, the thing is, you can just delete it, because if we're doing Flux, if we're doing GitOps, if we're doing eventual consistency, it's going to get recreated. Especially because we took care of actually not, for instance, in things that have state, like databases, going through a de-escalation process and not just deleting the original database. So we'll just wire it back up into the application. So, bottom line, now we've been changing infrastructure pretty fast without developers noticing it. We've been changing gears at the speed we need to because we've cut out the dependency. The dependency now is an interface. Developers get what they need when they need it, just as long as they don't forget to ask for it in the service definition file. We maintain the right service level objectives, but now we don't need to have complex changes because of dependencies for infrastructure patterns. What's next? Well, if this works for an IDP, I'm sure this also works for brownfield. So we've done greenfield, we're supporting new stuff. Now we're starting to do brownfield. So for instance, we use a lot of Redis cache, even in more legacy apps. So sure, now SREs in this case for brownfield approaches, instead of spinning up the cache resource, putting secrets somewhere and, well, doing what needs to be done, they throw a claim at a cluster. Things get done. And that's it. Thanks. Let me, in the meantime, try to address a question from Vilna regarding using Backstage and alternatives. Yeah, we looked at alternatives, and honestly, I don't know if in what curve we are, if we're ahead of the curve or in some other curve. We're actually moving away from Backstage because we ended up doing so much customization that we said, okay, now on its own portal for the service catalog, for the code generation templates, for all of that. And we'll see what happens. So perhaps in a couple of months, we'll have a different feedback, but now we're trying to do it outside of Backstage as well.
Thanks, Nuno. I was going to say in my intro that there was a really interesting project I worked on where we actually made a whole lot of change, and we were able to change infrastructure without developers even knowing and whatnot. But thank goodness we had someone here, who actually knows how things went. So great stuff. Okay, really quickly, our poll results, just to share the information. I think I'm sharing my screen. Are you using an IDP? Only 34% said yes. Are you using infra as code? It was about 50-50. 52% said yes, 48% said no. Dorimetrics, less than 20% said yes. And Backstage was 61% no, 20% planning, 14% testing, and 5% in production. I think Backstage is really interesting. It's a very nice jumpstart to have a portal, to have somewhere where to share information, but it easily runs into, you end up customizing a little bit here and there, and then it starts to wonder, is this really the right thing, as Nuno was mentioning they're experiencing. So it's a great tool. It's a great jumpstart. It might not be the best long-term solution, but at least it gets all the information in one place, and you have a kind of single bookmark to go to. So it's quite nice. There were a couple questions. We still have 3 minutes. There were a couple questions from Thomas. What's your perspective on your organization being around product value streams and not, as it seems, in verticals?
Okay, so out in our Streamline teams, it is, they maybe do investment or mortgage or digital channels with mobile banking and so on. And then we are, a platform team where we, everybody stands on top of our shoulders. So we have another setup on the central side, and our Streamline teams, they are very focused on delivering business value within, one area, you can say.
Can I suggest anybody who wants to know more? We have the DevOps conference coming up in just a couple weeks, October 23rd in Stockholm and 25th in Copenhagen. That would be a great place to interact with people and learn more about platform engineering. I'd like to thank again, Thomas. That was a great summary of what you're doing. And Nuno, that was, again, very informative and quite a high aspirational goal we can set for ourselves. So if we can all get down that we can develop and deploy new stuff in 8 minutes from the whiteboard to production, I think we'll all be much better off for it. So, and I really like the idea that you just change infrastructure and change tools as things are going and nobody notices. The more you practice change, the easier it gets, and then you can always be eliminating your technical debt without stopping everything. I think that's really cool finding. All right, well, thank you both, and thanks all of our audience for listening, and we'll talk to you next time.